yang belum request. Okay, for electrical system, we have few laws yang you belajar before this lah. This is not new things for you. Current's law, Kirchhoff current law, Kirchhoff voltage law. Okay, for the Kirchhoff current law, what is the theorem state that? Okay, all the currents that goes in is equals to currents that comes out. Okay, if something goes in somewhere, dia akan goes out somewhere juga. Yes. Okay, for the Kirchhoff voltage pula, it states that total voltage in a closed loop must be equal to 0. Okay, so kita kena ada one closed loop lah, baru kita boleh dapat the current the voltage is equals to 0. This one is equation for current for KCL. This is for voltage KVL. Okay, and then for this control system, all this current and voltage equation we can have in terms of transfer function. Okay, alright, so let's go towards this table terus. Okay, we will have three components. This is linear components: resistor, capacitor and inductor. Why all these three components we call as linear? Kenapa? Pernah dengar about linear and about active and passive element? Okay, so macam pernah? Okay, all these three, this is active or passive? Passive element. Why? Yes, if we have one jumper connect dengan resistor je, pusing lah jadi close loop pun. Is there anything happen? Tak ada. Okay, unless kita sambung with battery. Yes, battery ke power supply ke direct current, direct voltage ke. Okay, same goes with the capacitor and inductor, RLC. This is RLC, we call as passive element because dia tak boleh generate current. What happen kalau kita connect dengan current source? Current tu dia as active or passive element? Current source. It is not active, not also passive. Current source. Okay, because if we have current source, kita mesti ada voltage source. We must have voltage source dulu, baru ada current. That is why current is not active, not also passive. How about voltage source, Haikal? Now, how about voltage source? Active or passive? Haikal, where are you? Where are you? So voltage is active or passive? Voltage source. Normally voltage source kita tulis VS kan? VS pula. Sorry, VS. Voltage active or passive? Voltage VS ataupun V supply, it will be active. Sebab in order for current to flow, dia mesti ada voltage supply. Okay. Alright, so this is all the passive element for components, resistor, capacitor and inductor. So for all these three elements, we can have in time domain and also in frequency domain. So for time domain, kat sini yang T is the time domain, for resistor, capacitor and also the inductor. Okay, and for frequency domain yang S. If you observe here, in time domain kita tulis huruf kecil. In frequency domain kita tulis huruf besar. Okay. Alright. So the resistor is comparison dia kalau dengan mechanical, ini adalah spring. Sebab dia tak ada S kan, dia tak ada derivative. Okay. Dia tak ada first derivative, second derivative ke, tak ada. Okay. For capacitor, it is integration. Ini logo pula. Ini simbol apa? Dia macam cacing. Integration. Kang, ya, kamiran. Dia kena integrate dulu baru ada limit. This one kan limit dia. Okay. Alright, so this is integrations for capacitor 1 over C. And then integration to the T, tau. For frequency domain, dia akan jadi 1 over SC. Sebab when we integrate this one, kita akan dapat 1 over S. Kan? Integration, bila kita integrate the value, kita boleh dapat 1 over S. Okay. So 1 over SC. And then untuk inductor, this is first derivative. For first derivative, LS, ini current lah. Okay, so dia ada S kat sini. Ini beza. This is no S. This is 1 over S. This one is S. Okay, ni tak ada S. Alright. So yang ini adalah impedance ZS yang biasa R 1 over S C. This is for inductor LS. Okay. This one tak perlu sangat because sudah tahu pun ohms V equals to IR and so on tu. Okay. One example, we can solve for electric circuits in order to get the transfer function. Okay, tapi we need to know the input and output. Sama lah, kalau before this you guys solve buat KVL, you will have the input supply. For example, kat sini is the V in adalah input. Okay, yang connect here normally V out. So V out adalah at this point parallel with the ni apa? Capacitor. Parallel with the capacitor, meaning that V out adalah VC kan? Sebab dia concept of parallel voltage. Okay. Sama juga for the electrical part. Sama with the mechanical part. We need to understand ataupun we need to identify what are the input and output. Input normally the supply. Tak kira lah kalau kat sini dia letak as the V in. Kalau dia letak VS ke, all the supply. You assume as macam ni lah, kita ada satu supply. Kalau biasa you guys tengok the circuits yang ada supply kan, connect with the battery ataupun voltage source. Okay, the output will be yang hujung, dia akan connect V out kat situ ataupun dia letak V out as this one. Okay, tak semestinya dekat capacitor, might be inductor or resistor also. Okay, and then we need to determine what are the other components that we have in the circuit. And then kita tengok we can do the KVL or KCL. Okay, for this one, ini comes from the first one here, comes from where? Datang dari mana tu? KVL. KVL ni dia tak akan beri. Ini dia berilah, tapi dia tak akan bagi because you need to know the KVL or KCL. Kalau nak pakai current, KCL lah. Okay, tapi in between KVL dengan KCL, KVL akan lagi kerap pakai kan. Kalau you solve circuit, KVL juga. So KVL is very important untuk ingat. Jangan lupa terus dah habis satu-satu subjek yang belajar on the KVL. Okay. And then kita juga tahu from this circuit, output dia adalah dekat sini kan. So dekat VC. So you will have two equations dah dekat sini. This one is the second equation, VC. Okay. So this is equations kita. Kita replace with the VR is for supply. Ini daripada table ni lah. From this table tadi. Kalau tanya saya in this table, kita akan beri ke tak during the exam? Jawapan dia is no. So you need to, sama juga macam mass spring damper, you need to memorize. Tapi as for now, saya belum jumpa lagi lah soalan yang masuk RSC in test. Okay. Alright. So this one is bila kita dah masukkan from the table for the resistor, for the inductor, and also this is output ataupun VC lah. Okay. This one. Since kita tahu V out adalah dekat capacitor. So we can replace as this one lah. And then our main purpose kita nak V out over V in. Kan? This one. Yang ni. Because V out over V in is the transfer function. Okay. So you susunlah the equation V out over V in. Kalau rasa macam madam susah lah huruf N, huruf C. Normally kalau dekat dalam soalan dia akan bagi nombor. Sama juga macam yang kita buat tadi. Dia akan bagi nombor L equals to 10 ke, C equals to 5 ke. So you just masukkan the value. Okay. Alright. And then this one sama je macam tadi. First thing, yang ini kita kena jadikan as nombor SAR. S square. So yang lain kena bahagilah dengan dia. Okay, so this is the transfer function. Final dia macam tu lah. Cuma bila you do the exercise ataupun dalam soalan, dia akan bagi value. For L berapa, C berapa. So dia akan jadi satu transfer function. Bukan dalam bentuk huruf lah. Alright. So lebih kurang je dengan mechanical part tadi. Cuma this one is in terms of capacitor, inductor and also the resistor. Okay. Ada soalan tak? Ni another example. Sama je dengan tadi. If you solve some electric circuit, sometimes you akan jumpa E kan? Kan? Bukan V. Because dululah zaman saya belajar dulu, bila saya guna buku-buku rujukan yang lama-lama punya dipakai huruf E. Yang lama punya. And then saya notice yang latest sekarang kita banyak pakai V dah tak pakai E. So kalau you tengok yang E tu, it is V equals to E. Sama je. Okay. Actually ini je sebenarnya, saya tak nak pergi detail sangat on this one sebab this one pun sama je dengan tadi. Cuma kalau tadi dia inductor dulu kan, lepas tu baru dia resistor. Okay. This one dia pakai konsep voltage divider. Ingat voltage divider? Apa kawan dia? Kawan voltage divider. Current divider. So kalau kita ada voltage, mesti kena ada pair dengan current divider. Okay. Tapi untuk for our subject, saya tak nak pergi too detail lah on this one. For voltage divider, current divider and also for this electrical part. Macam yang sebelum ni saya beritahu, agak jarang kita masukkan kat dalam test. And this is normally for electrical part, soalan circuit dia tak banyak beza. Circuit dia lebih kurang pusing-pusing macam tu je. Okay. And this one is, you guys dah pernah belajar on op-amp? Kat mana? Instrument kan. Okay. So this one in op-amp pun kita boleh dapatkan in terms of dia punya equation juga. Okay. This one lah. Alright. So basically itu saja sebenarnya for chapter 2.